So continuing on, we're going to put all of our focus in this video on our point parameter. And why are we going to do that? Well, at this point, everybody should have figured out that the line really does lie at the very foundation of our crowd simulation system, at least the crowd simulation distribution system, because it's going to dictate where every single character gets copied to. At this point in time, we have said that all of our lines will have 2 points plus the maximum balls per bench. So let's say that we have 6 balls being placed. So that would give us 8 points. And then we run it through a delete stop to knock off those 2 endpoints. And we're back to 6 balls being placed. But the problem is that line is then merged in with our original bench. And that original bench then gets copied all over the place. So we have a bench on every single row, on every single column, with a line sitting flush on top with 6 points. That means we have no natural look to the crowd in the stadium because we have the exact same number of people on every single bench. So in this video, we're going to focus on randomizing the number of points that we're going to have on each of these lines up to the maximum balls per bench. So how are we going to go about randomizing the number of points? So keep in mind, everything that we're talking about is going to be affecting this parameter right here. So we're going to be enhancing this expression like crazy. Well, fortunately for us, we have an expression function that we can use in Houdini called rand. So let's go ahead and jot it down so that you guys can see what it looks like. Rand is a very powerful expression. Artists use it a lot, all the time. So rand basically takes something in as an argument and generates a value between 0 and 1. And let's spend just a minute, Steve, and talk about that. If you read the help file, the language is such that it looks like you could actually reach 0 and you could actually reach 1.
Well, the language is fuzzy. It's not technical language and it's not mathematical language, so it leaves with speculation as to...
It says from 0
between,
to 1.
To 1. So
yeah, there is fuzzy. No... It's just from 0 to 1.
Yeah.
And unfortunately, it's not really from 0 to 1. It's between 0 and 1. At least that is what we have pretty much come to the conclusion of ourselves. What we did is we created a very simple network that had 1 million points, and we created an attribute on our in our network, and we randomized a number, and we basically randomized that number for every single point in the network. And then we pulled it up in the spreadsheet, and we analyzed the numbers from the lowest all the way up to the highest. And so there's a million numbers there. We never hit 0. We never hit 1. We came so close to 0. And for 1, we was like 0.999999998. We came so close to 1, but we never actually hit 1. So it may hit 0 and it may hit 1, but we have never seen a scenario where it actually does. So in this particular case, we are going to go with the value that's generated from a rand is between 0 and 1. Steve, it looks like there's one more thing you want to add to that.
No, I'm actually good.
You sure?
I'm good.
Okay, so this is what we are going to go with. Now the question is, what are we going to put in here? So the very first thing that you may think is, well, how about we take the expression that we're already using on our point parameter and put that in there. Let's give it a shot. So I'm going to come in here real quick just to save some space. We'll erase all of this stuff out. And let's throw in 2 plus our maximum balls. I'm going to start abbreviating because it's too much to write. So maximum balls per bench.
Just you wait until we have all of our expressions when we're over at Houdini.
It's going to be crazy because we're going to be working with all of these stamp functions. You'll see. But anyways, all right, so that looks pretty good. So let's say, once again, we'll just stipulate that this guy is a value of 6. That's what's been set on him. So 6 plus 2 gives us 8, though that's technically irrelevant. It's fed into the rand, and some number between 0 and 1 is generated. Okay, not 0 and 6 or 2 and 6, but a number between 0 and 1, so we're left with some sort of float. Basically, let's say we got 0.8. What are we going to have, 0.8 points?
Nope.
Because, I mean, if we plug this expression in, that's what Houdini is going to see as you're trying to do. I want the random of blah, blah, blah. Okay, fine, 0.8. And then it's going to see 0.8 being applied to the point parameter of the line SOP and turn around and say no. And it will replace that value with 2. Why? As I said in the last video, every single line has at least 2 points. That's the minimum number of points on a line. So you may be thinking to yourself right now, well, let's multiply that number. It would make sense if we were to multiply this number between 0 and 1 by the maximum balls per bench. Well, if we had 0, hang on one sec, Steve. Steve was wanting me to add a little bit extra, but I'm working freestyle right now. If we were to multiply 0 by that, we would end up with 0. If we were to multiply random by this guy right here, then we would have, and this again being the result, and what I mean by that is we take our random, we take the result of that, and we multiply it by the maximum balls per bench. I knew that's what you wanted me to add in there. But as I'm saying, I'm just kind of freestyling down here. We take these numbers, we multiply this, and we end up with a range that looks like 0 to, let's just stipulate for a moment that it does return 1, right?
Yeah.
So maximum balls per bench, so all the way up to 6, 1 multiplied by 6 would give us 6. So now our points parameter could see some value between 0 and 6. Now, we could truly see 6 right now. And you may be thinking to yourself, how? You just said that the random generates numbers that lie between 0 and 1. So if you had 0.999998 multiplied by 6, you wouldn't actually get 6. It would be 5.999. You would be really close. But here's something that you need to always keep in mind when working with expressions on integer parameters on any node in Houdini. And that is that Houdini will round the value up as opposed to truncating the value. So let's say that we ended up with 3.6. That was the result of multiplying our rand, this right here, by our maximum number of our maximum balls per bench. Let's say with that we end up with 3.6. Houdini's not just going to truncate this off because we can't have a decimal value in our point parameter because this is very finite. It's how many points are there? 1, 2, 3. We can't have 3.6 points. That's not possible. So what Houdini does is it looks at that value, and if the value is 0.5 and above, it rounds it up. So this 3.6 would really be viewed as 4 points. So in the scenario I was drawing out for you down here, if we had a value of 5.998 generated, Houdini would round this up to 6 for us, and there you go. Okay? So now we're starting to get a bit of a better picture of how rand works, and that we're going to need to multiply something by rand to get a usable number in point. But and right now, as a beginner, you might be feeling really proud of yourself, but when you start plugging these numbers in, you find that your crowd doesn't look natural. The number of balls that you have on the first bench is the same number of balls that have been positioned on every single bench, and that doesn't look good. And why is that? Well, we are using an expression right now all the way back up here on our line SOP, and this expression is calculating the number of points on this curve over here that's sitting on our original construction bench. And then that guy gets duplicated everywhere. So even though we've used the fancy expression rand, the number's the same on every single bench, on every single row and column. So we're going to need to do something else. And you may think to yourself, all right, hang on. It's good. We've got a number that's changing on every single row right now. We're already using that. If you recall from a copy further down the network, we stamped back up what row number we were on. That data was very important in calculating the width of our bench. Well, I can use that in this expression here, and so now I have another variable that's changing on every single row. But we're going to run into another problem, and here's that problem. Let me go ahead, if you guys don't mind, I'm going to create a new clean slate that we can work on. So let's say that here is a row, and let's say we've got 2 balls, we've got 1 ball, we've got 3 balls. Okay? So, all right, using that stamped up row number worked out really well. But how does our network work? It copies this information around. So on the middle column, we're going to have 2, 1, and 3. And then moving on around from there over here, we're going to have 2, next row, 1, final row, 3. So it looks a little more randomized. I mean, it's definitely better than there being only 3 balls on every single bench throughout the whole thing, but that's not going to cut it. So you may think to yourself, all right, well, When we copy our bench back to each row, we then feed into another copy where we duplicate this information around to each of the columns. So what if we were to generate a stamped variable there and send that back up so that we have a row number and a column number? Well, if we combine those two, we get something that's more random than this, but you can still see a pattern by the way the numbers lay out. So it would be awesome for us to generate a unique number on every single row. And when I say every single row, I'm talking about every row for each column. So let me go ahead and clear all this out, and let me show you how we're going to do this. So we shall begin with the standard drawing, and I thought I'd got away from drawing the stadium, Steve. I guess not. So something like this, I guess.
This really does demonstrate quite the power of stamping, because we're stamping not by our immediate copy, but by a copy that's even further down in the network and still able to reference that right up at the top of our network, which is just incredible.
Exactly. I needed some more room at the top, so I decided to redraw it. So this, let's go ahead and come over here and down to here. So let's say that we have 1, 2, 3, 4, 5. So we've got 5 different rows. Now bear with me for 1 second. Steve, tell everybody a nice story. It's been a great weekend Saturday, hasn't it?
It has been a great weekend.
For those that are wondering, Steve and I went out and ate some Mexican earlier, and we talked about some Houdini. I was hoping that everybody's enjoying the content we're putting together. Okay, and that concludes the filler. Okay, so right now, if we were to analyze our rows, because remember we have a row number that's getting stamped back up, what would we see? We would see the following: 0, 1, 2, 3, 4. And that's brilliant. We need that data right now for determining the width of our bench. And in a minute, that's going to be very useful for us. But if we were to look at that same data on the next column, it would also be 0, 1, 2, 3, 4. And it would also be the same over here with 0, 1, 2, 3, 4. All right. Well, let's take a look at our columns. So if I was to just draw a line up like such, this would be column 0 all the way up because it's our first column. So that's our column. So same thing over here. This would be column 1, but all the way up. And then finally over here, following along with the same idea, this would be column 2, but all the way up. So using these numbers, can we come up with some sort of very simple expression that will generate a unique number for every single row in every single column? For those of you that are following along, if you're not average or above with math, let's say you're struggling to follow along, this is an awesome time to pause the video and try to work this out on paper first. And then come back and see if what you've worked out matches.
And don't just think in terms of maths, think in terms of logic, because the solution is very logical in a way that if you were to go and number these guys so they had a unique number, how would you go about doing it? Which order would you flow through the diagram numbering these guys? And that will help you out when you come to generate an expression.
Precisely. And so pause. Unpause. Okay, so
they wouldn't technically hear you say unpause if they pause.
Well,
just pointing that out.
If they did, and then came back, they're like, oh, I was supposed to pause then. So they'd hear me sooner or later. So these R's that I've drawn, what do they really represent? They represent row numbers. Right, Steve?
Yes.
I just wanted you to say something. Columns.
That's cool.
These guys represent column numbers. So column number 0, column number 1, column number 2. There's one other piece of information that we have, and we can get access to this up on the asset itself, and that is the total number of rows. So num rows. And the total number of rows that we have right now is 5. Remember, everything is 0 base, so that's why we begin our first row at 0, but 0, 1, 2, 3, 4.
That must have been really hard to draw.
So we have 5 rows being set by the artist up at the asset level. Here is the expression that we're going to use. If we take our current row number and we add to that our column number, our current column number, multiplied by our total number of rows, this right here will generate a unique number for every single row on every single column. Let's go ahead and spend just a minute and map this out if you guys don't mind. I'm going to use some deadly skill seen right here in this video to draw out kind of a map. There we go. All right, so let's go ahead and graph this guy out. As a matter of fact, we know how many of these, let's see, right about there looks good. So row 0, 1, 2, 3, and 4. And we've got 3 columns with our example here, so let's go ahead and row 0, 1, and 2.
Cool.
Or columns. So column 0, column 1, column 2, and then over here we've got row 0, row 1, row 2, row 3, and finally row 4. So let's look at that expression being populated with numbers. So when we visit the very first row, so we're about to solve for this, oops, I don't want to draw it that far. We're about to solve for this guy right here. Okay? Let's look at the expression. Rn. What's Rn going to be first? This is our row number. What row number are we on? We're on row number 0. So 0 plus. What column number are we on? Again, 0. Times. What is our total number of rows? 5. Again, reaching up to the asset itself and grabbing that information from one of our custom parameters. So we put 5 in there. Let's work out this awesome math. 0 plus 0 times 5 gives us, ladies and gentlemen, 0. Outstanding. All right, let's take a look at the next one. Next one is going to be row number. We're now looking at this row number right here. What's that value? 1. So 1 plus. Now check this out. You're about to see that while we remain on a column, the number is going to stay constant within these parameters or within these parentheses. And here's what I mean. We're still on column 0, and we're multiplying this by the row number, which is the total number of rows, which is still 5. So this value is still 0. We've just gone up to 1. So the answer is 1. So going up here to 2, well, 2, because again it's going to be 2 plus, this guy doesn't change. So he's still 0. So 2. So the next one would be 3. The next one would be 4. Now the next time we see a change is going to be when we flip up here to the next column. So on that column, so here we are, we've already worked out all the math, but you guys just didn't want to see me continue to multiply 0 by 5. We start back off with what row number? So keep in mind, this is where we are. We're row number 0 once again. Let's work it out. 0 plus column number. What column number are we on? Column number 1. And that column number remains the same all the way throughout the calculation of the rows on this column. So 1 times, and we already know that this number is constant, we have a total of 5 rows. So if we were to work this math out, 0 plus 1 times 5 is 5, plus 0 is 5. Ooh, interesting patterning developed. The very first column we got 0, 1, 2, 3, 4. Now over here we got 5. Wow. Well, let's work out the next number. So the next number is, once again, what row number are we on? We're on row number 1. So we're going to have a 1 right here plus, well, once again, this is constant. So we know that 1 times 5 is always going to be 5 on this particular column. So 1 plus 5 is 6. The next one would be 2 plus 5. 7, 8, 9. Outstanding. So let's pretend I worked all the math out here for those of you following along. If you're any confused, take a moment and do this. Any confused. Boy, I love the way I speak sometimes. Now moving on to the next thing. We're on the final column, So on the final column, the very first thing is what row? So we're right here, 0. So let's go ahead and take 0. Let's go ahead and add to that. What column number are we on? We're on 2. 2 times 5, because again, number of rows is a constant. That gives us 10. 10 plus 0 is 10. Okay, so we know it remains the same. So moving up to the next one, row is going to be 1. So 1 plus 10 is 11, then 12, then 13, and finally 14. Absolutely amazing. We have now created a unique number, though we did have to do something new. That is, we had to stamp information coming from the copy of column 1 around to all of the other copies. So remember, we're going to have to throw that stamp data in there and bring it back up. And we're going to be reusing the stamp as well that we're currently using to drive the size in X for our bench. So
yeah, which was on our copying for all of our rows. We've got row number stuff.
Got our row number, exactly. So we're going to be reusing that one, and we're going to be creating a new one. And that brings us back to what Steve said just a few minutes ago. I'm writing out some very small stuff, but when we begin typing this out, the expression's going to be huge. Because this right here, this is referencing a stamp
parameter.
This is referencing a stamp variable. And then this right here is referencing up on our asset. Just those guys right there, it's huge. So that ends up becoming quite monstrous. But basically, starting out with our first one, the numbers that you would truly see if you were to look at this would be 0, 1, 2, 3, 4.
And this is going back to when I was saying about trying to solve this for yourself. It's logical how we're numbering these guys.
Absolutely.
Because if I was to just go and give these guys a number, this is one of 2 possible ways I go about doing it.
9. And then finally, while we're running out of room over here, I shall do the best to say 10, 11, 12, 13. Oh, what do you know? It went all the way to 14. And it went to 14 right there. Beautiful. And that's the way it gets copied over. That's the way the numbers are going to look. But why are these numbers important? Well, now I have a unique ID, so I'm just going to call these guys ID. Steve can call them whatever he wants when he gets in there. With this unique ID, I can now apply that to the random, and that gives me some stuff to work with. So let's go ahead and jump down. And remember, we're still working with the points parameter on the line SOP. So now if I was to take rand and feed in my row number plus my current column number times, and again, those guys are going to be big stamps, my number of rows, this right here is going to generate a value for us between 0 and 1. So now if we take that a step further and go with our, now remember, we've got to take our maximum balls per bench into account, and let's not forget the 2 points as well. So now if we take this guy down and do something like this, 2 plus our maximum balls per bench times our, and we're going to throw some parentheses in here in just a minute, just to make it clear, but times our rand, so we're just bringing this guy down, with our row number plus column number times our number of rows. Now if we were to take this guy, and let's just group all of that together. So we end up with our number, we add to it, we're always just going to add 2 to it because, well, why? We need those 2 points to exist because we're going to be deleting those 2 points out in just a second. Okay, so this is going to give us a value that is going to go between 0 and our maximum balls per bench.
And when we say
and
this,
the only reason we get to this, oh well, there's I'm not counting the 2.
Yeah, we're going to say this is just the parentheses.
Just as a 2 right here.
Fantastic.
In fact, let me just throw this in there. And pretty much everything I'm going to talk about now, I'm disregarding this guy. He's a convenient thing. He's just there because we need to delete 2 out in just a minute.
So we're now talking about how many audience members are we going to have as opposed to how many points.
Right. So if you really want to get technical, it's this plus 2.
Yeah, so it's between 2 and that plus 2. But we're ignoring that.
But let's just say that we know that 2 is getting removed out in just a second. So we're going between 0 and the maximum balls per bench.
Cool.
And we know that the only reason we're getting to the maximum number of balls per bench is because, in essence, we're getting a number between 0 and let's say that our maximum balls per bench ended up being 6. So we may end up with a number of 5.9. Okay, and what did I say about an integer parameter? Houdini rounds that value up in there. So in this particular case, it would round it up to 6, and that works out great. Or does it? Let's think of a problem we have. The only...
Oh, sorry. I was going to say, before we even go to there, the beautiful thing is now each of these benches has a different value because of the way we're generating that random number.
Absolutely. This, as we start duplicating around, I see where you're going. We'll back up.
Yeah, just to reiterate, I guess.
Just to reiterate. No, that's completely cool. Now, we know that this expression down here is going to be using stamped data that's coming back up in the network. So as that single line gets copied around to every different row, it has a unique number, and that unique number is going to end up generating a random number of points. But we still have a problem.
Yes.
The problem is it's unfair. Isn't life so unfair?
Sometimes.
It's unfair because we're going between 0 and the MBPP. Wow, that's awesome.
That's horrible.
I didn't realize how challenging that was to say until I suddenly decided to throw it out there. The problem is the only reason we're reaching the maximum balls per bench is because of rounding that Houdini is doing. So the only way we could possibly reach that number is if we happen to fall between 5.5 and 5.999 whatever. So a very small window will give us this high-end number. And for 0, same thing is going to happen to 0 between 0.0001, okay, because remember we can't actually hit 0, up to 0.4999. This will give us a rounding down to 0.
Yeah, so we're unfairly biased. The very beginning and the very end have a smaller chance of being hit than all of our numbers in between.
And what Steve means by that is when we hit 0.5, that can now round up to 1, 0.6 rounds to 1, so all the way up to a value of 1 will round to 1, but 1.1 rounds to 1, 1.2, 1.3, 1.4 rounds to 1. So we have a full value in there, going from 0.5 all the way up to 1.499, that can give us a value of 1. But 0 is just less than 0.5. And for our maximum number of balls is, again, a difference of less than 0.5. So we need to find some way that we can basically work with the numbers in such that it's fair for distribution, or for a number count to be generated where everybody between starting out and maximum balls per bench has a fair chance of being selected. That's the word I'm looking for. So how are we going to go about doing this? Let's go ahead and make ourselves some more room. I think everybody gets the idea here. What we're going to do is we're going to shift everybody so that we get out of the floor, if you will. I want to actually take us up to the maximum balls per bench and beyond. And we're going to do that by saying 2 plus 1 plus. Now, that's going to give us, so now, let's say that we had that point 0, 0, 1. Well, that plus 1, now remember, again, everything I'm talking about, we're disregarding the 2, okay, because we know for a fact the 2 is removed out. So I'm talking about results not taking the 2 into account, okay? We just have to have it there because the delete's coming up next. So 0.001 gets shifted to 1.001. And remember when we hit that 5.99? He just got shifted. He's at 6.99. All right, well, that's good and bad. Rounding's going to hurt us here. Rounding's going to hurt us because what's going to happen to this guy? He's going to get shifted up to 7, and now if we just accidentally, stumbled on 6.99, we could end up with a bench with 1 ball extra on it, and we don't want that. So there is another expression that we can use called floor to basically truncate our number. And so what this would give us, if we were to take the floor of that value, it would simply give us 6. If we were to take the floor of this value right here, what are we going to get? It's going to give us 1. So if we were to take this guy right here and pump him through a floor expression. So let's take the floor of the result of our maximum balls per bench times, we'll worry about parentheses in just a second, that's multiplication, I promise you, ladies and gentlemen, times the rand of the current row number, which is stamped data, plus current column number, which is stamped data, times our number of rows, closing off that guy, closing off our rand, closing off our floor. And now let's go ahead and just put the whole thing, since right before floor to the end of there, we're now going to come out with a very solid number between 1 and 6, all the way up to our maximum number of balls, and every number in between has a fair opportunity of being selected, as well as 6.
Exactly, because the floor expression now counters that rounding we were getting. So anywhere from 1 up to, but not quite to 2, gets basically truncated. It's taken back down to 1, which means we're countering that rounding, whereas before, if we went over 1.5, we'd round up to 2. So that now means that we're getting from 1 all the way up to nearly 2 belongs to 1. From 2 all the way up to nearly 3 belongs to 2. So everyone is getting a fair chunk of space that gets associated with him. The problem with this is when we take the floor of going almost up to our maximum balls per bleacher, that's going to drop us down 1. That's going to drop us down to 1 less than our maximum balls per bleacher. Well, that's not what we wanted, so that's why we've had to add that 1 in at the beginning.
Exactly. Okay, we have this. It works really well. There's one other thing we can do. We can go ahead, and because let's just say that we plug this expression in. Works fantastic. But let's say that the result that is generated, an artist looks at it and goes, it's all right, but it could be better. It would be nice if we were to go all the way back up and we had the maximum balls per bench attribute added up at the asset. If we added one more thing up at the asset, up under audience, and that is seed, so that an artist can see the distribution of his crowd and go, let me try another one. And he can just change the seed value and the distribution changes. Again, leaving the maximum balls per bench the way it is. So that way he can simply scroll through a seed number until he finds a distribution that he likes. This is very easy to do. We'll simply add that seed parameter in, and then we'll modify our rand. So I'm only focusing on this guy right here to this parentheses. So if we were to change that to say rand, and take in our current row number plus our current column number times our number of rows, and we take this information and come over here and let me group all this together and now we're still inside the rand. We multiply that by our seed that will reference back up on the asset, and then close off the rand. So the rand is between here and here. The artist can now scroll through that number, and as he scrolls through that number and the network recooks the result, that seed value is changing, and as that seed value is changing, the artist is seeing a different distribution of the crowd amongst all of the benches.
Because now our unique ID can be thought of as both the ID we had before and multiplying it by the seed. So if we change our seed, our unique ID changes, our random number changes, and thus we're going to get a different end result.
Exactly. So in this video so far, what we've taken a look at is the efforts we're going to place on the expression for points that is going to allow us to randomize the number of points on each of our benches, on each of our columns. And we first came up with a unique ID number for every single bench based off of our formula that we used right there. And then we ran that information through a rand. We multiplied it by the maximum balls per bench. And then we saw that it kind of worked nicely because of rounding, but also because of rounding, it set up an unfair scenario where we would not hit the maximum balls per bench that often. And we simply fixed that by shifting our result, and then by shifting our result by adding 1 to it, we then saw that we needed to take the floor, because if we did not take the floor, of the result of the multiplied maximum number of balls per bench and the random, then we ran the risk of going one ball over the maximum number of balls. By taking the floor, we simply truncate it, that number, the decimal portion, and there is no rounding to take place. Everything worked out great. And then we had what we needed. We finally put ourselves a seed parameter in for an artist and tied that into the random expression itself, allowing full control for the artist for selecting the distribution that he believes looks best for the scene in question. So with that, Steve, is there anything you want to add before we jump over into Houdini and put this simple expression together? And I say simple expression, it is a simple expression, but it's big.
Yeah, so the logic behind it is fairly simple, but when we go over into Houdini, it's kind of going to become ginormous because of the sheer amount of stamping that we have to do.
Because again, this guy right here, remember, we have to use the stamp expression, which is pretty big in itself. Stamp expression. Reference up to our asset. Reference up to our asset. Just keep all that in mind. That's going to make the expression look really big. But in the end, if you just kind of mentally weed out all of the expressions that we have to use to gain access to the numbers, this is what we are building. Okay? So with that, I guess we're ready to jump over into Houdini.
Alright, so let's jump over into Houdini, and the first thing I'm going to do before we tackle any of this is to sort out the problem we were having with our folders on our parameters.
Oh yeah, that guy.
So let's jump over to Houdini, and it turned out at some point during the creation of the folders I'd accidentally checked one of the checkboxes, and that was causing the problem. So let's bring up the type properties for our asset, and over here on our bleachers folder I'd accidentally checked N tab group. If we uncheck that guy and click accept, and then bring back up our parameters, you can see
Hey.
now our folders are behaving as I was expecting them to behave.
Instead of audience being in a tab all by its lonesome at the very bottom of this dialog.
So,
but that's the great thing
cool.
about our videos. Instead of reshooting it and just pretending it never happened or just fixing it off camera, we're just human, Steve. We leave our faults in the video and then we show people how to fix them, because you never know. Somebody following along may have also accidentally clicked that, or may have, for some strange reason, been clicked by default, and they would like to get their folders set up like this, or their tabs set up like this. So now they can see how to do that.
Fantastic.
All right, now it's time to start working on that itsy-bitsy expression.
There's something else worth noting at this point. We had two solutions for calculating the lengths of our benches. The first solution was our mass-based solution, where we did actually stamp up our row number. The second solution, which is the solution we decided to stick with, we didn't stamp our row number. Instead, we stamped up the attribute that we created. It's not a problem. It just means that here, instead of just stamping a new column number as a stamp, we also need to create the row number as a stamp.
But you guys have seen this. We have done this.
Yep.
We just didn't stick with that.
Yeah, we just chose to go with the other solution. But had you kept with the mass-based solution, you already have row number being stamped up, and you won't need to do this step. If you followed us and kept with the
solution number 2,
yep, then we're going to just need to create a row number stamp. So I'll create both row number and column number stamps right now.
Excellent.
So on our copy benches for rows, where we're copying our bench up for each of our rows, I'm going to create a new stamp, which I'm going to call row number. And I'm simply going to stamp up $PT, since the point numbers we're copying to go 0, 1, 2, 3, and so on. So that's our row number stamp. I'm then going to come down to where we copy for our columns. So we've got our single column, and that gets copied all the way around. I'm going to turn off point numbers. That's much nicer. Come over to our stamp tab, make sure we check stamp inputs, and here I'm going to create a column num parameter. And in this case, I'm going to stamp up $CY. And you may ask yourself, well, why are we stamping $CY, where for row number, we stamp $PT? It's fairly simple. On this copy, we're not using template geometry and copying to points. Instead, we're using a number of copies. Whereas $PT refers to the point number we copy to, $CY refers to which of these copies we have. So for our first copy, the copy number is 0, then 1, 2, 3, and so on. So now we've got our column number being stamped up, and we've got our row number being stamped up.
Go back to the row number real quick.
Sure.
What did you use for a variable name again? Yeah,
row
that's what
number?
I thought. Let's make that row num just so that
so
we keep our
column
convention the same. Yeah.
Sure.
Since we're going to see both of these variables being used in the same expression. That's right.
So I've got a row num parameter spelled ROW capital N lowercase u and m, and a column num in the same manner.
Excellent.
Fantastic. I'm also going to create our seed parameter so that when we come in to write this expression, we can simply just write out the expression, copying it from the whiteboard, and we don't have to worry about halfway through our expression, jumping away, creating a parameter, and coming back. Sound cool?
That's the only thing we're missing.
Exactly. So I'm going to right-click on our digital asset, come down to Type Properties, and inside our Audience folder, I'm going to create a new float. I'm simply going to name this to Seed. I'm going to lock this with a minimum of 0.001, although a negative seed isn't an issue. I just want to have a positive seed just for our slider, because I don't want this to actually hit exactly 0, because then if you think about it, we multiply our unique ID by 0, and then everyone would get 0, and we'd have the same number on everybody. So by restricting this so it is a positive value as opposed to allowing positive and negative, we avoid that case where we may hit 0.
Right.
I'm also going to up the maximum just to around 100, so we have a larger range. It also means if an artist comes in and clicks a slider, they're going to change the value more significantly when they move the slider. With that, if we accept that, we should have everything in place to go and take this expression that we created on the whiteboard and implement this into Houdini. And other than referencing parameters with stamps and everything, it's going to be really simple.
Okay.
So that parameter we've seen already is the number of points that we have up on our line stop. So here's our audience template line, and currently in points, let's bring up an expression editor and maximize this so it's full screen. So we have our 2 plus our max balls per bench. Well, here's our 2, here's the max balls per bench. So let's start constructing the other parts of this expression that need to sit around it. We need to add 1. So just come over here, 2 plus 1. Plus our max balls per bench. We need to take the floor of everything that's coming after this point. So I'm going to stick with the way that you drew it out on the whiteboard and create these parentheses, even though they're not actually essential for the calculation.
Right.
And let's create our floor expression and close off our floor expression. I'm just going to create some space so we know whereabouts we're working currently in the expression. So we've got 2 plus 1 plus floor of our max balls per bench. So floor of our max balls per bench. We now need to multiply this by our random number. So let's multiply this by a random number. Everything we have left to do now is going to focus on generating that random number, and we've seen on the whiteboard how we're going to do that. We're going to take our row number, add it to our column number times the number of rows, multiply all of that by our seed. All of this sits inside our random expression, and once we have that in place, that's actually the entire expression in place. So we're going to take the random, and I'm going to space this out again so we can see.
You can put 2 parentheses in it, and then multiply the output of that by
the seed, and then create the inside, because once we create that inside, it's going to be lengthy.
Yep, exactly.
Fantastic. So this is going to be for our row number plus our column number times number of rows.
That's going to be the guy that generates the unique ID for every single row for every single column.
And we're going to multiply that by our seed parameter that's up on our asset. So all that's left now is getting our row number and our column number and getting our number of rows. So how are we going to get our row number? Well,
you know what? Here's an interesting way to do it. Go ahead and just use the same, basically the same shorthand that I did back over on the whiteboard. So go ahead and do a capital R, a small n. Yep, now plus, and then parentheses, the capital C, small n times num rows.
I'll call that rows.
Okay, that works.
Now we do on the whiteboard have parentheses here. We don't technically need them, but I'm gonna keep them there so that it matches exactly what we had on the whiteboard.
Now let's start.
So row number. We know that we've got this as a stamp parameter, so we're going to need a stamp expression. Where do we stamp this from? We stamp this for our copy benches for rows, copy SOP. So our copy benches for rows. And what did we call the parameter? We called it row num, after we decided to rename it to keep with our column num. And default value of 0 in case something breaks with our stamp expression. So that's our row number. I believe I created a parenthesis, and I already had a parenthesis. Plus that, and then this should close off our round.
Yeah, and it does. Okay.
There we go. No, that should close off that, and then that should close off our round because we multiply by seed. Fantastic.
Oh, yeah. Okay, so let's...
I added an extra parenthesis by accident and then removed it.
Alright,
so this is our stamp expression. We now need to get our column number in a similar manner. So stamp Now in this case, we're on the copy columns copy stop. The parameter that we stamped was column num. And again, we'll use a default value of 0. And rows is a parameter up on our asset that was indeed called rows. So close off our rows expression. That closes off our column number times rows. That closes off our row number plus our column number times rows, which gets multiplied by our seed. Outside of that, we close off our random expression. Outside of that, we close off our floor expression. And that's closing off the outer parentheses that's around the floor expression before we add 2 plus 1.
Plus, at this point, you can go ahead and simplify 2 plus 1 down to just 3.
Let's just simplify that to 3.
Nice.
And accept this. And bring our visibility down to where we copy our columns. And then turn on points. And I believe we do need to set in our audience folder. Yeah, a max balls per bench greater than 1 would help us out, because currently we're going between 1 and 1. Everyone's going to get 1. So let's set this to something like 4.
And you can already see if you look around.
So a really easy way to see this, I'm going to push space 2 to come into a top view, and push W.
There you go.
So we've got 3, 4, 4, 2, 1, 1, 3. So yeah, we're getting random numbers all over the place. Let's modify our seed.
Nice.
Everyone changes, modify our seed. Everyone changes. That's fantastic. So we've still got issues with the front, and we can see that here. The front having
there's one before
being too cramped together because we want to bias towards the back. And we'd also like to create the ability to
offset.
Exactly, offset, so that we can say, okay, do we want to have empty seats or not?
Okay, yeah, both. Well, okay, two things.
Wow, yeah, 2 things. Offset in terms of position, and offset our expression in terms of allowing us to have empty seats.
Basically, the offsetting is where we take this and basically just bias it more towards the right or to the left. And it'd also be nice if we gave the artist a checkbox where they could say allow empty seats, and then 1 of these, 2 of these, 4 of these seats could end up having no balls whatsoever copied to them. And it's, again, just simple modifications to the expression that we're working with.
It's funny because you say offset, and the simple modification to our expression involves offsetting the values in the expression, which is why I was thinking about empty seats. So
it's just, the big thing is, keep in mind why we're doing floor and why we're doing +1, because I think everything else is very clear. It's the +1 and it's the floor that these two guys work together. There's 2 different problems that we are accomplishing, that we're fixing, basically, and that is, 1, fairness. It's not very fair in the way we reach the maximum balls per bench. So by adding 1 to the entire thing, it shifts it such that instead of going, and I hope you guys don't mind, for those of you that are getting tired of this, you can go ahead and just stop the video at the moment, but I don't see any problem, Steve, with us spinning just a second.
I think it's very cool that we make sure that everybody knows exactly what's going on, just in case there was any confusion, because I really believe this is one of the only complicated parts that you could maybe get stuck on.
Yeah. So let's say that our maximum balls per bench is equal to 5. Well, our random number generates 0, 1, 2, 3, 4, but thanks to some rounding, we could actually hit that 5, but it gives a very small area in which we might hit it. 4.5 up to
4.9999.
Exactly. So by adding 1, we shift everybody. So this starts at 1, 2, 3, 4, 5. Though we have a problem now, as we had 4.9 a second ago, now we could have 5.9, which, if Houdini rounded that up, gave us a value of 6. And now we are maximum balls per bench +1, and we don't want that kind of a scenario. So by coming in and using floor, then that's going to clean it up, if you will, because it's just going to truncate all of our numbers. And with that, just keep in mind, now the range runs from 1 one ball all the way up to the maximum number of balls that we requested.
And everything is nice and fair.
And everything is nice and fair. Exactly.
Fantastic.
So with that, Steve, is there anything else you'd like to add into this video?
This is absolutely everything for this video.
Okay, so with that, that wraps it up. Thanks a lot.